Abstract. Claude Skills, introduced by Anthropic in October 2025, represent a paradigm shift in organizational AI adoption through radical simplification. Unlike previous approaches requiring complex protocols and substantial technical infrastructure, Skills employ a deceptively simple architecture. Markdown files containing task instructions, optional supporting scripts, and minimal metadata. This simplicity enables organizations to rapidly develop and deploy specialized AI capabilities across functions without extensive engineering resources. This article examines how skills redefine work design by democratizing AI capability development, enabling rapid organizational learning cycles, and potentially flattening traditional skill hierarchies. Drawing on research in organizational learning and technology adoption, we analyze skills implications for capability building, knowledge management, and workforce transitions. Organizations that strategically cultivate skills engineering as a core competency while addressing governance challenges stand to gain significant competitive advantage in the evolving landscape of human AI collaboration. Introduction. The introduction of Claude Skills in October 2025 marks a significant inflection point in enterprise AI adoption. While previous AI integration paradigms, from ChatGPT plugins to Model Context Protocol (MCP), required substantial technical infrastructure and specialized expertise, Skills reduced the barrier to AI capability development to something remarkably simple: writing clear instructions in Markdown format. Willison, 2025. This radical simplification has profound consequences for how organizations structure work, develop capabilities, and manage knowledge. Organizations have spent the past 2 years grappling with how to systematically integrate large language models into operational workflows, often with disappointing results despite substantial investment. Brynjolfsson and McAfee, 2017. Skills offer a different path. Instead of building complex infrastructure first, organizations can rapidly prototype and iterate on task-specific AI capabilities using tools already familiar to knowledge workers. What makes skills noteworthy from an organizational design perspective is their potential to fundamentally redistribute who can create AI capabilities and how quickly organizational learning can occur. When capability development moves from specialized AI engineering teams to distributed practitioners who understand domain problems, the traditional division between developers and users begins to dissolve. Edmondson and McManus, 2007. The Claude Skills Landscape. Defining skills in the AI capability context. Claude Skills constitute a lightweight framework for extending AI model capabilities through human-authored instructions and supporting resources. At their core, skills are folders containing a primary Markdown file with task instructions, YAML metadata for discoverability, and optional executable scripts or reference documents. Anthropic, 2025. The system operates on a token-efficient architecture. During session initialization, Claude scans available skills and loads minimal metadata, typically a few dozen tokens per skill, with full content retrieved only when contextually relevant. Willison, 2025. This architecture represents a significant departure from previous approaches. ChatGPT plugins required web service development and API specifications. MCP demanded implementation of a complex protocol specification covering hosts, clients, servers, and multiple transport mechanisms. Anthropic, 2024. Skills, by contrast, leverage a critical insight. LLMs can interpret natural language instructions effectively, making formal protocol specifications potentially unnecessary overhead. Skills depend entirely on the model having access to a file system, navigation tools, and code execution capabilities, the same environment required by coding agents like Cursor or Claude Code. Willison, 2025. By outsourcing complexity to the execution environment rather than the capability definition layer, skills make capability creation accessible to non-engineers while maintaining technical power. State of practice, early adoption patterns. As of October 2025, the skills ecosystem remains nascent but exhibits rapid growth. Anthropic's initial release included skills for document creation across PDF, DOCX, XLSX, and PPTX formats. The shareability of skills presents both opportunity and challenge. They can be copied, modified, and distributed as easily as any text file. Willison, 2025, predicts a Cambrian explosion in skills which will make this year's MCP rush look pedestrian by comparison. Organizations face a capability maturity spectrum. Early adopters can immediately leverage example skills for common tasks. More strategically sophisticated organizations are developing proprietary skills encoding organizational knowledge, brand guidelines, data processing standards, regulatory compliance procedures that represent genuine competitive advantages. A third category involves meta skills, organizational capabilities for systematically identifying which processes benefit from skills development and integrating them into operational workflows. Organizational and individual consequences of skills. Organizational performance impacts. Skills compress cycle times for specialized tasks by making expert level performance accessible through natural language interaction. Where previously an organization might require specialists in specific technical domains, a well designed skill enables competent generalists to achieve comparable outcomes through AI augmentation. Research on AI augmented knowledge work suggests that such task level augmentation can improve productivity by 30 to 40% for suitable tasks while maintaining or improving output quality. Delacroix et al., 2023. Beyond individual productivity, skills create organizational learning advantages. Traditional enterprise AI implementations suffer from long feedback loops spanning months. Skills reduce iteration cycles to days or hours, enabling rapid experimentation and organizational learning. An organization can prototype a skill, deploy it to a small team, gather feedback, and refine, all within a work week. However, skills also introduce performance risks. The ease of creation means quality varies dramatically. Organizations lacking governance frameworks for skill validation, versioning, and maintenance may find themselves with proliferating undocumented capabilities of uncertain quality. Technical debt in a new form. Individual worker impacts, capability redistribution. For individual workers, skills represent both opportunity and disruption. The democratization of AI capability development means that domain experts can now directly encode their knowledge without intermediating through software engineering teams. A compliance officer can create a skill for regulatory document review. A marketing manager can develop a brand voice skill. This direct authorship reduces dependency on technical specialists and potentially increases job satisfaction through greater autonomy. Hackman and Oldham, 1976. Yet this same democratization threatens traditional skill premiums. Tasks that previously justified specialized roles may become commoditized through skills. Research on technology driven skill obsolescence suggests that workers face pressure to continuously move up the value chain, focusing on tasks requiring judgment, creativity, or complex social interaction that remain difficult to encode. Otter, 2015. Early evidence suggests heterogeneous responses. Some workers enthusiastically adopt AI augmentation, experiencing enhanced efficacy and job satisfaction. Others resist, viewing AI tools as threats to professional identity or as quality compromising shortcuts. Lebovitz et al., 2022. Skills simplicity may reduce resistance by making the technology feel less alien. Workers author their instructions, maintaining a sense of control, but organizational change management remains critical. Evidence based organizational responses. Establishing skills governance and quality frameworks. Organizations cannot simply enable skills without governance frameworks. The most effective approaches balance accessibility with quality assurance through tiered governance structures. A pharmaceutical company implementing skills for regulatory document processing established 3 tiers: experimental skills available only to their creators, validated skills peer reviewed for team use, and certified skills that had undergone formal quality assurance for regulatory compliance. Effective skills governance includes version control and documentation, review protocols based on skill scope and risk, testing requirements, retirement procedures, and security screening. Deloitte, implementing skills across consulting practices, developed a skill maturity model distinguishing between personal productivity skills, minimal governance, team collaboration skills, peer review required, and client deliverable skills, formal quality assurance. This differentiation allowed innovation while protecting quality where it mattered most, reducing approval time from weeks to days. cultivating distributed skills authorship. Rather than centralizing skills development in technical teams, leading organizations are building skills authorship capabilities across their workforce. This distributed approach leverages domain expertise where it resides while developing AI literacy throughout the organization. Key elements include foundation training on how LLMs interpret instructions, templates encoding best practices, internal showcases celebrating effective skills, mentorship programs, and community platforms for sharing and collaboration. Microsoft, rolling out skills internally across product groups, established a Skill Champions network where experienced practitioners provided guidance to colleagues developing new capabilities. Within 6 months, employee authored skills were being used in over 60% of Claude interactions, with satisfaction scores indicating the distributed model produced more contextually relevant capabilities than centralized development had achieved. Integrating skills into organizational learning systems. The most strategic organizations view skills not merely as productivity tools, but as organizational learning infrastructure. Each skill represents codified expertise. Collectively, they form a living knowledge base that evolves with organizational understanding. This learning centric approach involves retrospective skills development after complex projects, onboarding integration for new employees, cross pollination mechanisms, capability gap analysis, and evolution tracking. Bain and Company implemented a skills observatory, tracking which skills were developed, adopted, modified, and abandoned across client engagements. This meta analysis revealed patterns in skills transferability and effectiveness, informing both training priorities and strategic capability development. These insights created a flywheel effect where skills use generated learning that improved skills strategy. Managing workforce transitions. As skills reshape what work requires human judgment versus AI execution, organizations must proactively manage the evolving employment relationship. Effective strategies include transparent communication about changing skill requirements, reskilling pathways developing capabilities complementary to skills, role redesign participation, involving workers in reimagining their roles, performance metric evolution, and psychological safety for experimentation. Accenture, implementing skills across consulting operations, established Future of Work labs, where teams could experiment with skills augmented workflows in low stakes environments. This participatory approach reduced resistance, improved skills quality through practitioner feedback, and generated insights about effective human AI collaboration that informed organization wide implementation. Developing skills aware career pathways. Organizations are recognizing that skills create new career trajectories and talent requirements. Progressive talent strategies include recognizing skills architecting as a career path, specialists in translating organizational knowledge into effective skills, valuing hybrid expertise combining domain knowledge with skills development capability, making skills development core to performance frameworks, rewarding community contribution, and encouraging external ecosystem engagement. BCG restructured consultant career progression to explicitly recognize skills development as a valued contribution. Senior consultants were evaluated partly on whether they developed reusable skills benefiting multiple client engagements. Within a year, the time required to bring new consultants to competency in specialized domains decreased by approximately 35%, attributed largely to skills based knowledge transfer. Building long term organizational AI capability. Establishing skills engineering as core competence. As skills become central to operational effectiveness, organizations must develop institutional capabilities for their strategic development and management. Skills engineering as an organizational competence involves capability sensing, systematic mechanisms for identifying where work would benefit from skills, strategic prioritization based on frequency, consistency, and value, platform thinking, treating skills infrastructure as a foundation others build upon, and ecosystem management, engaging with the broader skills community while protecting organizational interests. Integrating skills into continuous improvement. Skills' rapid iteration potential makes them natural fits for continuous improvement methodologies. In lean contexts, skills serve as Kaizen tools. When teams identify process inefficiencies, they can rapidly develop skills addressing root causes. Six Sigma practitioners are discovering skills enable more sophisticated data analysis, without requiring specialized statistical expertise on every team. In innovation processes, skills function as rapid prototyping tools for AI augmented capabilities, enabling organizations to test value before committing to larger investments. Developing human AI collaboration literacy. Perhaps the most critical long term capability is widespread organizational literacy in effective human AI collaboration. Skills make this literacy more accessible by reducing technical barriers, but organizational investment in developing judgment about when, how, and whether to employ AI augmentation remains essential. Effective programs address task suitability assessment, output evaluation, prompt engineering fundamentals, ethical reasoning, and security awareness. Organizations are finding that effective literacy development goes beyond training to include embedded learning in workflow through AI pair programming, real time coaching, and retrospective discussions. Conclusion. Claude skills represent a watershed moment in organizational AI adoption because they radically simplify access to AI capabilities. By reducing AI augmentation from a complex engineering challenge to a knowledge documentation exercise, skills democratize AI capability development in ways that may fundamentally reshape organizational work, learning, and competitive dynamics. For organizational leaders, several strategic priorities emerge. Invest in distributed capability development, cultivating broad skills authorship capabilities while maintaining appropriate governance. Treat skills as knowledge infrastructure, recognizing them as organizational learning artifacts that codify expertise and create compounding advantages. Proactively manage workforce transitions through transparent communication, complementary capability development, and participatory work redesign. Develop institutional AI collaboration literacy, helping workers develop judgment about effective AI augmentation. Engage strategically with the skills ecosystem, contributing where appropriate while protecting genuine competitive advantages. The simplicity of skills is precisely what makes them profound. By making AI capability development accessible to domain experts, skills accelerate the shift from AI as specialized technology to AI as general purpose infrastructure woven throughout organizational work. Organizations that engage these questions thoughtfully, treating skills not as mere tools, but as catalysts for organizational transformation, will be best positioned for the evolving landscape of human AI collaboration.